there, and thank you for taking time today, because I know you were even this morning collecting data in schools. So yeah, clocking up quite a lot of miles around the country. So next, I'm trying to remember which of these is your one. Do you remember which? That. Okay, so I'm delighted that our next speaker is Dr. Malu Gomides, who's another postdoctoral researcher in the School of Psychology. She's working as part of the Arithmós project, which is a collaborative project between UCD and TUD, and it's funded again by the IRC, the Irish Research Council. And the Arithmós project is looking to engage children, families, teachers and policymakers to improve mathematics learning. So thank you very much, Malu.
So hello everyone, my name is Malu. Last year I presented the results of the pilot study that we conducted within the context of the Arithmós project. And today I'm excited to show the preliminary results of our main project. So I am a member of UCD Music and Math Cognition Lab, led by Dr. Santos, and our lab main goal is to develop research on numerical cognition and music science in individuals with typical development and learning disorders across the lifespan. So today I'm going to show some preliminary results of the Arithmós project. This project is a collaborative initiative between UCD and TUD, and is being funded by the Irish Research Council. And this project is a multi-dimensional project, which the main goal is to engage children, families, teachers and policymakers to improve math learning. And to achieve this goal, we implemented several strategies. So we designed a cartoon video explaining math anxiety to children. We created a workshop to support teachers' management of math anxiety in the classroom. And we are currently organizing a meeting with policymakers concerning the curriculum design. And the research piece of this project is a RCT study testing the efficacy of digital games on math learning. So I'm going to show the preliminary results of our RCT study. So our main question is if digital games can improve math skills. So we talked about digital games before this morning, and indeed there are several evidence showing that digital games is a promising tool to promote math education. And they can include several elements that can be very helpful to math education. So for instance, they can create an informal environment where children can learn. They are designed to be intrinsically rewarding and fun. They can provide immediate feedback so children can understand where they are making mistakes. And they can include adaptive features so that the level of complexity is calibrated to the child's current level of development. So our first research question is to evaluate if digital games can improve numerical skills. So in particular, we focus on symbolic magnitude comparison skills. These skills entails the ability to judge the magnitude of numbers and to choose the largest one. It could seem like a trivial task to us adults, but for children is an important predictor of math achievement. So for instance, in this study from 2009, you can see that a larger score in the symbolic magnitude comparison predicted the performance on math years later. A second research goal was to investigate if the games can enhance the arithmetic calculation skills. So the basic arithmetical operations like addition, subtraction, division, and multiplication. And to test this hypothesis, we assessed 164 children. This represents partial data of our main study. All children were 4th graders, and we allocated them to 3 different conditions. So the first one was a control passive group, in which children engaged in regular school activities. The second one was a control active group, in which kids engaged in sessions with educational videos and control digital games. And the third one was an experimental group, in which children engaged in sessions where they play a game that were specifically designed for this project that aim to improve math performance and reduce math anxiety. So this game was developed by our partners from TUD. It's called 7 Spells. It's a card digital game in which children needs to combine numerical cards to capture the cards of their opponents. And they can use these yellow-green cards to call it spell cards. So they are special cards that could boost their movements, and they can capture even more cards. So the goal is to capture the cards, and the more cards they capture, the higher their scores in the game. So children in these 3 conditions, they engage in these activities for 5 weeks, and we assessed them in 2 different time points. So in the baseline and immediately after the intervention, so in the post-test. We designed a protocol to assess their math skills, so their numerical skills and calculation skills, but also to assess how they feel in general and how they feel about maths. And for the purpose of this presentation, I'm going to focus on 2 specific outcomes. The first one is the SIMP test, which is a symbolic numerical comparison task. The SIMP test is divided in 2 subtests. We presented pairs of numbers to children and asked them to choose the largest one. In the first part, they see single-digit numbers, and in the second part, they are presented to 2-digit numbers. They also responded to calculation task. They need to solve some math problems, and these problems were presented both visually and auditorily, and we measure both the reaction time and accuracy. So now I'm going to show the results, and I'm going to start with the 1-digit subtest of the SIMP task. So here in this plot, in the x-axis we have time, so pre and post-test, and in the y-axis we have the score in this SIMP task. And in green we have the line in green is represents the children in the control passive group. In blue we have the children in the control active group, and in yellow we have the children in the experimental group. So we performed some mixed linear regression models, and we are particularly interested to see if there is an interaction between time and group. So what we found is that there is indeed an interaction, a significant interaction, meaning that children in the experimental group, so the line in yellow, they presented a large increasement from pre to post-test in comparison to children in the control active group. Concerning the results of the 2-digit subtask, we found that there is also a significant interaction, but this time we found that the experimental group presented a significant increasement from pre to post-test in comparison to the control passive group. Now I'm going to show the results related to the calculation component. So here we can see by this plot that the experimental group showed increase from pre to post-test, where both the control passive and control active show a decrease. And we found that there were significant interactions, meaning that the experimental group presented a large increasement from pre to post-test in comparison with both groups. Concerning the reaction time, although we observed that overall the groups presented a decrease in the reaction times, we didn't find a significant interaction. So, in conclusion, we found that playing educational games was associated with a significant improvement in the ability to compare numbers. We also found that children who engaged in playing 7 spells showed a significant improvement in their ability to solve arithmetic calculations. And these results have important implications for the educational context. So we recommend that integrating educational games into the classroom has the potential to enhance mathematics education. And also for future studies, we suggest to explore the long-term effects of this intervention. Indeed, we measure a follow-up assessment, so 2 months after the end of the post-test, and we are currently analyzing this data to see if these effects they are enduring or not. So, thank you very much for your attention.